All right. So hi, everyone. I'm Chrissy Rissmeyer, the Director of Digital Library Development at the UC Santa Barbara Library, and I'm here with three other members of the Project Surfliner team. To help us stay on track, they'll each introduce themselves when it's their turn to present. Next slide. So if you aren't already aware, Project Surfliner is a collaboration between the UC San Diego and UC Santa Barbara libraries with contributions from UC Santa Cruz. And together we're developing, deploying, and maintaining shared digital library products built on Samvera components. But Project Surfliner is more than shared code, it's the collaboration itself. We're combining our campus's strengths and experiences to build tools and approaches that help each of us address our local needs. The name comes after the Amtrak Surfliner route that connects the two founding campuses. We started working together in 2018 and now collectively maintain 8 products and components, each of which is named after a historic California train route. Next slide. So today we'll be talking about 4 of those products and components. And to explain all of the train names, Comet is our implementation of Hyrax, which is a staff-facing digital object management platform. Super Skunk, which is my very favorite of all of our train names, is Comet's metadata API. Daylight is a framework for building general discovery platforms for Comet, and Tidewater is an OAI PMH endpoint that uses configurable metadata. Next slide, please. So from the beginning, we've worked from a set of shared principles, and I want to touch just briefly on 2 of them today. Our goal from the start was to develop a modular suite of applications, sharing the engineering workload while giving each institution the flexibility to assemble a digital collections infrastructure that meets our local needs. All of our code is maintained in a shared GitLab repository, which we deploy to separate installations. And importantly, we don't maintain separate institutional forks of the code. Most of our products and components, including the other discovery platforms, serve really specific, tightly scoped functions. And while Comet, our staff-facing Hyrax-based system, is large, it offers a robust set of management features, which through customizable workflows and our implementation of configurable metadata, its architecture has been flexible enough to meet the needs of all of the campuses. Next slide, please. However, when we started thinking about our general purpose discovery layer, that really challenged those principles. As we began the planning, it became clear that divergent campus requirements and unique use cases made a single shared discovery application impractical. We were essentially at the point of deciding that each campus would just have to develop their own discovery platform independently, which, to be honest, was not exactly what we wanted, and we felt pretty stalled on the tracks. Next slide, please. Oh, go back one. There we go. But then a series of conversations led us to switch tracks and lean more into our principle of feature abstraction. So we decided instead to develop a framework for composable micro-frontends, allowing us to share the technical work while still giving each campus a fully customizable and independent installation. And with that, I'm going to hand it over to Elisa to tell you more.
Hello, my name is Elisa Pierce. I am the front-end developer and user experience designer at UC Santa Barbara Library. I came to the library just 2 years ago with 20 years of web experience. This is my first role in a library space, and I was amazed by the scale of content a single library manages online. I kept thinking about how I would need to maintain all the different web properties. And I wanted to consolidate where I could to minimize a change needing to be made many, many times. The conversation started discussing well-known frameworks like React and Vue, which came with large code bases that require significant dev time over their lifetime, especially with updates and vulnerabilities that arise with them. In my career, I had found those frameworks problematic, as they often change dramatically, which came with a large lift for smaller teams to keep up with. I was hesitant to back them as a solution for our needed discovery platform. And since Surfliner operates on the microservices architecture, this one concept kept sticking out, a micro front end. So micro front ends, similar to microservices, break down applications into smaller, manageable pieces. And these chunks aid in collaboration since each component can be built independently of each other. It is useful for teams where different features or segments can evolve without impacting each other. And once our tech lead highlighted web components that could be used in these front ends use core APIs, I was really getting interested. So core web APIs are a standardized out-of-the-box browser features that essentially are the capabilities that build our frameworks and our applications, our interfaces. Um, this wasn't shiny new tech. These web components could be built as the main building blocks for our front end using fundamental JS, JavaScript, HTML, and CSS. Blocks that can be deployed separately and potentially used in many locations with only one code base, which also meant I could use them in custom templates we have in like our SpringShare products or even other third-party theme sites. I also knew this meant they could last. Being built from the web platform's fundamentals, they were more resilient and will be easier to maintain. Additionally, relying on these core web skills also expands the pool of available developers and makes it straightforward to onboard or train team members to support this style front end. So David T and I worked together to identify what elements a discovery platform needed. Checking out the Blacklight app and our current platforms, we found many that could be shared. And so this is a list of all the possible components in our library that can be used. Standouts are the search bar, the result list, and the object viewer. We also laid out the plan to collaborate together. Each campus can contribute to developing the common components. This will make up Daylight. Collaborating to ensure that the components are mobile friendly and accessible. These components then can be deployed as needed to our sites, and where we wanted to customize, we can, allowing design choices at the campus level. Dynamic content enters the picture using API endpoints from our backend. So to get a little bit more technical, the core web API used to make the web components are custom elements. You get to make your own HTML tags and functionality, basically. We have HTML templates, which is just exactly like it says. It's templates of HTML that are reusable. And then we have the shadow DOM. DOM stands for Document Object Model. This reads our code and prints it onto the screen. The shadow refers to the layer that can override the light DOM without creating side effects. So bolding some copy in the shadow DOM would not change all the copy to bold. For development, I run a Docker image for Daylight and our local discovery ADR Lite. Docker packages up each app and its dependencies so I can launch a complete site locally in seconds, develop, make code changes, and then test in a realistic environment. We use JavaScript here. We extend the HTML element. We attach a shadow DOM in the constructor, and we use lifecycle hooks. A connected callback will run and insert anything that we might need. Disconnected callback handles cleanup, removing anything that we loaded into the page from memory. Update, passing in data, renders API-driven content. Dispatch new result will emit events. This allows other components to know what's going on in that component and share that information to the user. We also register the component with our custom elements.define method and use it declaratively in a standard HTML page. In short, encapsulated, reusable, lifecycle-aware UI that renders from APIs and communicates via events. And now I'm going to kick it over to David T. to talk about some of our challenges and other opportunities.
Yeah, hello, I'm David Trujillo. I work for the UC San Diego Library as a web developer. Today I'll be talking to you about some of the challenges we faced building Daylight. Next slide, please. Okay, challenge one, integrating third-party technology into our web components. We found that if the technology wasn't built with the Shadow DOM in mind, the integration could have issues or may not be possible. For example, we attempted to integrate a third-party file viewer into one of our web components and ran into rendering issues. After some sleuthing, we discovered that the viewer was hard-coded to display in the regular DOM. There wasn't a lot we could do there, and we really liked the file viewer, so we resolved this issue by taking it out of the web component and placing it on the page instead. Moving on to challenge two, capsulated styles can be awesome, but they can also be tricky. Capsulated styles are a selling point of web components, but attempting to use several individually styled web components in concert as part of a larger system requires some thought. For example, if we'd like to create a custom campus look and we're starting with web components that use generic styles, we need to decide where do we customize them, on the page level or the component level? And how do we customize them? Do we use regular CSS or do we use JavaScript to modify the shadow DOM? These are some of the questions that came up. Moving on to challenge three, we discovered that not all common web components are in fact common. An issue that came up during development was that the library of common web component, an issue that came up during development was that the library of common web components we thought we shared in the beginning turned out to not be so common. For example, our headers and footers in menu systems. And how did we solve this? We introduced local web components, that is, components that are campus specific. Then the challenge became, when do we make the decision to convert a common web component into a local one? We decided that, if a required change is campus specific, convert it to local, otherwise add it to the common library for the benefit of all. And for our final challenge, we have dry challenges is when implementing a component across several pages. The configuration of our common web components happens at the page level. For example, our search bar component allows for the display of an additional menu to be included in the render. But to do so, you must set the configuration value for it on every page you place a component on. A solution is to convert it to a local component and set the configuration value there, but that takes away from building a common shared library. And that wraps up some of the challenges we were talking about. And now I'd like to turn it over to David Moles to talk about Comet. So next slide, please.
Hi, I'm David Moles. I'm Associate Director for Digital Library Development at UC Santa Barbara. I've been there about 14 months. So when I came on, all of this was, we were well down this track. And it was interesting because I've been with UC Libraries since late 2014 and on the fringes of the Samvera community since not too long after that. I think I went to LDCX at Stanford in 2015, and that was my first exposure to it. And I think I made a little bit of a nuisance of myself at one presentation there because I was pitching doing API first apps and separating out the UI layers so that UI developers could use, UX developers could use tools that were their preferred tools or, excuse me, tools they're more familiar with rather than having to learn Rails and ERBs and the Rails way of doing things. And this was before Rails 7 and all the shenanigans about the asset pipeline that came along with that. So it was interesting to me to come into UC Santa Barbara and see that here was somebody who was independently with the Surfliner product had independently started going in that same direction. So anyway, I'm gonna talk a little bit about kind of the architecture of the whole system and how it fits together. Could I have the next slide, Elisa? So Comet is a Hyrax app, and in many ways, it's not too different from any other vanilla Hyrax app. I mean, various customizations, of course, but the main difference, I think, between Comet and most other Hyrax deployments is it is entirely staff-facing. It is not also the discovery layer for the content that it manages, which is why all of this. So I think one thing that the Surfliner project wanted to do early on was be able to publish out to a lot of different discovery platforms. So right now it's just two. We have Tidewater, which is our OEI PMH feed, and ADRL Lite, which is the discovery platform that integrates the Daylight components, what we've been talking about. But in the future, we could add other platforms. We could also use it, for instance, and probably will in the next year or two, to deposit content to a preservation repository. And all of this is built on the standard Hyrax event mechanism. So when you deposit an object in Comet, that starts various events. But then when you're happy with your content and happy with your metadata, you hit publish, and you can choose which endpoints, which discovery platforms you want to publish that to. And what happens is you get a standard Hyrax event published that's tagged with that particular platform for each of those platforms. And then the platforms then can just subscribe to the message broker for publish events for the content that they're interested in. Also, update events for content that's already been published, and unpublished events for when something's withdrawn or deleted. So the relationship between the discovery platforms and the dams itself is kind of all at arm's length, and it doesn't really matter how, or even to a certain extent, where those discovery and platforms are implemented. As it happens, ADRL Lite, which is basically it's the API backend, which is a Rails app, and the HTML that embeds the web components for the first version of this, is a Rails app, and it uses vanilla Postgres database and Valkyrie metadata models and all of that. But it doesn't have to be. It could be something completely different technology. And so long as it can subscribe to messages from that Hyrax message stream, it can still get those events. Personally, we're not excited about RabbitMQ. It's kind of a pain in several different ways, and it's also owned by the same people that are making our lives miserable with Bitnami charts and VMware licenses and all of that, if you're familiar. But it works, and because it's modular, that part would be relatively easy to swap out. The other piece that ties this together is having this metadata API. So when you get a publish event, it doesn't like come with all the metadata for the object. It just says, here's an object that's been published to you, and here's a URL that you can query to get more information. So then the discovery applications can query SuperSkunk, which is another separate Rails app that also uses Valkyrie, and it reads from the same database that Comet writes to, so it shares access to all the metadata. But it's more narrowly focused. It doesn't have a front end. It's just APIs, and it does a couple of things. The most important one is that it will crosswalk the metadata to whatever you need it for. So for Tidewater, it crosswalks it to Dublin Core for OAI. For ADRL Lite, it doesn't actually crosswalk it. You just basically get the same JSON that the Valkyrie uses. Not shown here is Starlight, our Spotlight implementation, and also Shoreline, which is our geodata discovery, and those also I think geodata uses Aardvark, but that SuperSkunk is responsible for for doing that crosswalk. Although under the hood, it's all using configurable metadata based on M3, similar to Allenson Flex, but more like software defined and less user driven. So this gives us a whole lot of flexibility. The other thing SuperSkunk does is because it's got access to the metadata databases, it also has access to all of the ACLs, the access control objects, which we model also as Valkyrie objects in the metadata database. So it can determine whether a particular platform has permission to view something, whether something's in fact been published at all. Not shown in this picture are also we use S3 compatible cloud storage for storing the actual digital objects. Santa Barbara uses Amazon AWS. UC San Diego uses Minio through the Cumulo high performance storage at San Diego Supercomputing Center. And the fact that we do that on two different platforms, one of which is not actual Amazon, helps keep us honest. And then we also use Cantaloupe as IIIF image server, which also talks to SuperSkunk in order to do those access controls and to look up the locations in S3 of the files based on the identifiers that it gets. So there is some administrative overhead associated with having everything split up like this. But I think the flexibility that it gives us is worth it. Let's see. Is there anything else to cover here? Well, just I see a question in the chat from Mark. We're not using Blacklight at all at this point. I mean, Comet uses it for the internal interface because, of course, that's what you get out of the box with Hyrax. But the front end components are completely independent. Because we didn't want to take on kind of the project work and stakeholder wrangling work of designing our ideal next generation discovery layer. What you'll see in ADRL Lite is very similar to what you get out of the box with Blacklight because it's based on an older Blacklight-based app that called ADRL that we run. But the plan is to, once we get all this stuff figured out and get digital asset management in solidly, then we can do that work of figuring out what the next generation looks like. Yeah, I think that's what I've got. So how much time do we have?
We had 2 minutes for questions.
All right, so
And I
maybe
just want to
no.
quickly show just real quick so you can see what we're talking about. Here are some components. They are all independent. Like David was just saying, we can come in here and make changes a lot easier. We can pivot when we need to. We can add more content, more design, more styling. This is an example of a component that's only being used on our ADRL Lite. And so this is our version where this is San Diego's version. So I just wanted to give you a quick look into what that is for us. And so this search bar, this behaves over here just the same as it behaves over here. And so again, we have multiple components that allow us to interact with the pages, and it builds very much like a Lego set. You get to put together all the pieces that you need, and then customize bits that would be unique to each of the campuses.